In the name of God, the most gracious, the most merciful. Today, God willing, we will discuss the subject of blast-resistant buildings. As well, we will discuss how to calculate the loads on it, whether statically or dynamically. Then we will try to make a comparison with the other loads, wind and earthquakes, and see the difference between them. And this, of course, is considered the second part of the extension of the last episode. Last time we talked about magazines and storages that we can store in explosives. And we know that it explodes at a safe distance. And we calculated this distance, and we knew how to calculate it. And this is the first subject, which is called how to store explosives. How can I store my explosives? The link to the episode is in the description below, so you can go back to it. The second subject that we will talk about today is the subject of constructing a building and trying to see if it will be able to withstand the next blast load or not. It is data on the basis of which you start designing this building to withstand the next blast load. I will have two ways to analyze it. Either I have a static solution or a dynamic solution. In the case of a static solution, and this is the subject of our first episode today, in short, we want to make a simulation of what happens when there is a car at a certain distance from an explosive car, of course, and there is a source of the explosion at a certain distance from my structure. How do I translate this to a model with this view and solve it statically in any software I have? I will produce the loads by myself. I will do it all by myself using the code for that, which is Unified Facility Criteria. This is, of course, approved for public release. There is no problem in using it. There is a set of conditions, about 14 to 16 conditions, and in the end they translate it to a specific curve. This curve can be dynamic, as we will see here. This will be the source of my dynamic work, or I can make an idealization and transform it into lines and start my analysis. In the end, I will transform the simulation of the case that we see, that there is a car or a source of the explosion hitting the building, and I will transform the pressure to a different value from the source of the building. The value of the explosion will be very high. As you can see, the value of the explosion is 80 kPa. But the surface and the side will also be affected by a lower value. In the end, we will transform this pressure to a force at each level, like an earthquake or a wind or a storm. Then we will study the building to solve the manual, or stop here to find the load manual and start the design. This is called the static analysis. The dynamic analysis is not very different because the curve that we saw in the static analysis, that we made an idealization and transformed conditions into a set of factors to calculate the pressure on each side of the building. We will use this same curve as a time history in any other software. Through the shape of the curve that is related to time and pressure, I can generate the waves that come on my building. As you can see, the propagation of the wave starts to collide and it becomes a wave. The wave is more or less, and then it crosses our building. This will be the title of our next lecture about dynamic analysis. Now you know the story that we will talk about. God willing, we'll discuss a very important comparison between blast load and wind and seismic, because we all know how wind and seismic field simulation or approaching the image through blast load will make a lot of difference, because blast load is a pressure. So it does the work of wind to the extent of the difference in scale, and it is also waves and time dependent. So it works like an earthquake with the difference in waves and with the difference in the duration of each of them as time dependent. So if we approach the issues through these two topics, it will make it easier for us. That's why I started with this part, because it will make a lot of difference in understanding the subject. As we will see in the explanation, let's start with the first topic in our lecture today, which is what are the similarities and differences between the blast load on one side and the wind and earthquakes on the other side. Because this is what will simplify for us the concept of the blast load affect the buildings that are hit by it. If we compare it with the wind, they are both pressures. The wind is an aerodynamic pressure that hits the building and exits. The blast is also a pressure that hits the building and affects it. But the duration of the wind is minutes or hours, but the duration of blast is milliseconds. It does not complete a second. It is milliseconds. Therefore, the wind load, the pressure that is generated from it, is much less than the blast. The blast reaches its doubles, and it can be as much as 20 or 30 times its power on the building. So this is from the point of view that I compare it with the wind as a pressure that hits the building, but from the point of view that I compare it with the earthquake, it is that there are waves in both cases. The earthquake, the waves come from the ground motion occurs. It is a wave that causes the building to vibrate, and the building then gets a global response. Each building responds to this, but in the case of the blast, there are waves, depending on whether it's far or close to my building. If it is far from my building, the whole building will be affected globally, and it will have a full response. But if it is very close, it will only affect the solid part, or close to the explosive charge, or the only part that will be affected is the localized response. There is also a very important similarity in the subject of the load shape itself, the load shape between the earthquake and the blast. Both of them can have a time history because both of them are time dependent. The seismic is related to time, to the duration that occurs in it, and also the blast is related to the duration that occurs in it. And we will see this in the blast, something called TD, duration time also. I can draw the time history of each one of them and solve the dynamic based on it. There is also another similarity. The seismic, I used to solve it using the equivalent method, the static method that I turned the dynamic into a static. The same thing I do in the blast, I can turn the curve, which is the Terval exponential curve, into a triangle, and I work only with the peak force or the peak pressure that comes from it. And I print the building with something called the equivalent. All of these are similarities. Finally, not finally, the similarity between the wind and the blast is in the subject of the mass of the building. When it resists the blast is the same mass of the building. When it resists the wind, the more the mass of the building increases, the better it is in resisting the blast. And the better it is in resisting the wind, the opposite of the blast, the more the mass of the building increases, the less benefit it has for the blast to be a heavy building because it resists the blast, and so it is more affected in the end. All of these similarities try to bring us a little closer. So it is similar to the wind in some things, and similar to the blast in some things, and similar to the blast in some things, but with a difference. The duration time is milliseconds. The opposite of the blast is a second to 2 seconds, and the wind is a minute, and it resists the building for a minute also. There is inward and leeward. Inward is the pressure on one side, and leeward is the suction on the other side. This is present in the blast, but I explained it a little far, and the same thing in the wind. The wind is the same thing. When there is a wind that resists the building, it affects the building in its entirety, and the same thing in the blast. When there is a wind that resists the building, it affects the building in its entirety and does suction on one side and inward on the other. So we have done all the similarities and differences between the blast load on one side and the wind and the earthquake on the other. Thank you for participating in this session. Should you have any questions or feedback, please feel free to reach out to me via my Facebook page, LinkedIn profile, or by leaving a comment below this video on my YouTube channel. Best regards.